Okay. What numbers did we do? Number 10 is invisible. There it is. Yes, because one pair of sides is parallel. If one pair of sides is parallel, excuse me, no, that's not enough. Because one pair of parallel side, opposite sides is parallel and congruent. If a pair is parallel and congruent, then it is a parallelogram. Number 12 is no, because none of the tests work. 14 is no, because none of the tests are fulfilled, right? 12 and 14 are both halfway there, right? They would have to have, for number 12, it'd have to have both diagonals bisect each other, and number 14, it would have to have a pair of consecutive sides are supplementary. All right. Number 16 is a proof, so we can come back to it in a minute. Number 18 is x equals 2 and y equals 29. Number 20, x equals 30 and y equals 15.5. Number 22, x equals 40 and y equals 20. Number 24 is, oh, it's on another page. That's why I don't see it. Hold on. Give me a second. Really, it's just you do the formula and does it work, right? Twenty-four is yes, because the slope of AB is 1/7, and so is the slope of CD. And so AB is parallel to CD. The slope of BC is -6, and so is the slope of AD. So BC is parallel to AD. Since both pairs are parallel, it's a parallelogram. 26 is no, because opposite sides must be parallel and congruent, and they're not parallel because the slopes are different. Not congruent either, I think, but you're just using the slope formula, yeah, on that one. 28 we omitted. 30 is a proof. 32 is a proof. 34 is kind of a proof, but just like a tiny piece of a proof. And you can use theorem 611. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. We begin by drawing it. Oh, that's a construction one. Did I assign that one? 34? No? Okay. Well, good, because I didn't mean to assign it. What questions do we have on those? Okay. 20. It's got this. It's congruent to this, and it's got this little guy is 1/4 x degrees. This one is 8y minus 12 degrees. This one is 4x minus 8 degrees. And this one is y minus 8 degrees. Let's define x and y, so the quadrilateral is a parallelogram. So things have got to be congruent and all the things and things and things and things. So, what could we do? This is a weird one, right? He's like, yeah, that's why I asked about it. This one, a lot of the other ones we've had like opposite diagonals, and you'd use that. But we look at opposite diagonals, and we've got an X over here and a Y over here. So either system, or there's another way, right? So that doesn't work. What other things do we know about parallelograms? Anything? I already said that. That's what I just said. What else do we know? Opposite sides, true enough. Both useless. Good job. Go team. Let's go. All right, because sides, we don't know nothing. And we already talked about the opposite angles, right? We got different variables. We might use it, but if that's what we're using, we're going to end up with a system, which is theoretically a way we might be able to solve this one, although we need a 3x3 system because we have another thing that we don't know. It's kind of a hidden variable right there because there's these congruent things and we don't know how big they are, so we actually would need a third equation, which we could get, but I don't know how we're going to do that. So what else do we know about parallelograms? So yeah, they're diagonal split into congruent triangles. That might be useful, right? So this triangle is congruent to that triangle, which means the corresponding parts are congruent, right? Which we already see those, right? Those are congruent. So this is congruent to this again. That's kind of a little better. That eliminates one of the variables. We might could do something with a system, right? Because then we can just say this equals that, right? We can say this equals that. So we could do a system. So that's possible. Let's see if we have to or not. Actually, we might have to. I thought there might be an easier way. We might have to do this with a system. Might be really scary. What else? There's one more angle thing that might be helpful. It might not, but it might be. It's the one that I think one of them in the early problems was almost had this one. What about consecutive angles? What's true about those? They're supplementary, true enough. Right, consecutive angles are supplementary, which is what I was initially thinking we were going to use, but the more I look at it, the more I'm like, I think we still have an unknown thing. Because we could say this whole angle plus this whole angle equals 180, but we don't know nothing about this. So that's not going to help. So I think we're going to have to use a system. We've got two variables and two equations, right? We can set them up. So this one equals this one. Let's write that. Let's go ahead and write what we know and then see what we can do with it. All right, so y minus 8 equals 1/4 x. And then these opposite angles are congruent, so 4x minus 8 equals 8y minus 12. So we have two equations and two variables. That's a system. We can solve it. We can make that work. So we know probably two methods of solving a system. We've done a few systems in this class before, right? You probably know substitution. You probably know elimination, at least barely. Next year in Algebra 2, you'll know them a lot better. So what can we do to solve here? I think using substitution seems like a decent idea. This top one, we could solve for either x or y, right? And then we could substitute that in over here. So what do y'all want to solve for? X or Y up here? Y sounds fine. This particular one, you know, a lot of times there's an obviously better choice. I don't know that there actually is because of that fraction there. Normally that Y that's by itself would be great, but this one solving for X would kill this fraction, but I think Y works out just fine. Most things are going to be divisible by 4 anyway, so I think the fraction is going to disappear on its own without a lot of trouble. So that sounds fine. Solve this for Y. So Y equals 1/4 x plus 8 from this first equation. Oh, I didn't write that. This is this one. So now that that all equals Y, what can we do with it? Could we substitute it? What do y'all think? Why not? Trust. Are you having a twitch? Calm down. That all equals Y, so we can substitute it in the other equation for Y, right? So when we do that, we would have 4x minus 8 equals 8 times the quantity 1/4 x plus 8. Now we have one equation and one variable. We can solve that. So what do we do to solve that guy? Distribute. Trust. Bro. Distribute here. What is 8 times 1/4 x? It's what? It would be 6. It would be 8/4, which reduces, right? Because you multiply across the top, right? 8 times 1 is 1, and 1 times 4 is 4. What is 8/4 reduced to? What's 8 divided by 4? 8 minus 4 is 4, but 8 divided by 4 is what? 2. 2 times 4 is 8. Therefore, 8 divided by 4 is 2. 2x. And then what's 8 times 8? 64. Now what? Subtract what? 2x, sure, that's fine. Now what? He is not on a variable. We leave him alone. We had 8. Or we could go ahead and do the 64 minus 12. Clean that up, right? What's 64 minus 12? 52, definitely. And then adding 8 seems reasonable. Okay, now what? Divide by 2. X equals 30. Okay, so now how would we find y? What do you mean? Substitute the x that we already found in, right? Substitute it in where? At this or this? Yeah, where is this 30 gonna go in here? In the x. True enough. So what's 1/4 of 30? You have calculators. Right. You can grab one right out of that box. Oh, neat. Fifteen over 2. True enough. And then what's 15 halves plus 8? $31 halves, which is the same as 15 and a half, right? So, either way. New story, best of last month. I don't know why these photos apps now also have to give you notifications. Everything's got to be telling you stuff. Nobody cares. Okay, what other questions do we have? Okay. 16. Okay. Yeah, that's a good proof to do, actually. There's a lot of good puzzle pieces in there. Okay, so we are given that W, X, Y, Z is a parallelogram. We are given that angle W is congruent to angle X. We are given that M is the midpoint of WX. And we're supposed to write a paragraph proof, but I tell you not to do that. We want to prove that triangle ZMY is isosceles. All right. That's the only thing we're given directly is W is congruent to X, right? So this is congruent to this. We're also interested in this triangle, isosceles. So what we're trying to get to definition of isosceles, right? Or we're trying to get to base angles are congruent. We're trying to either get to base angles are congruent or definition where two sides are congruent, right? So what can we use from the information that is given up there? W is congruent to X, Y, Z, right? That big one. True, we can. This one is kind of bridging a couple of different triangles, but yeah, sure, that's good. Going ahead and putting down whatever we see is totally fine. So angle W is congruent to angle ZYX. Because of opposite angles of a parallelogram. Great. True enough. Now there, we can go ahead and put the other one. We may as well. What's the other one that is because of that same reason? Z. We can't just say Z. WZ. Yeah. You're right. To X. True enough. Angle X is congruent to angle. I'm going to do it as YZW to keep the way I wrote the direction, but I don't know that it's going to matter on this. So that's true, absolutely, because parallelogram. What else could we say? WX is congruent to not ZW, ZY. True. Sure enough. And what's the other one? And WZ is congruent to XY. Now these, I don't know if the angle ones are going to be as useful, but the side ones I think will be, at least one set of them. So this is congruent to this, and this is congruent to this, right? Okay, what else can we say? We've used the WXYZ as a parallelogram. We labeled W as congruent to X. Have we used W as the midpoint of WX yet? No. Here's what can we say because of that? If it's the midpoint, what's true about the segments that it is the midpoint of? They're congruent. So which two are congruent? Not Z to Y. So we're talking about using the midpoint bit, right? That bit. So not ZY isn't involved in that. W. So it is the midpoint of that. So which two segments are congruent? The littler ones, right? Which ones? W, that's the angle. This segment here, it's, look, you're good. It was the midpoint, so this is congruent to this, right? So what's that one called? WM. Right. Input 3. The opposite sides of a parallelogram. Great. WM is congruent to XM because of midpoint. All right, and label that. Okay, what can we do now? We're almost there, like super close. We can. We can say that this triangle is that congruent to that triangle. By which method? Side, angle, side. True enough. Triangle WMZ is congruent to triangle XMY because of side, angle, side. True enough. Easy peasy. Now what can we say? Remember, we're trying to prove Z and Y is isosceles. There's two ways to do that we know of, right? What are they? Two congruent sides. What else? The one we're not going to use, right? What is it? What? Not supplementary. No. Not with isosceles. Yeah, base angles are congruent. We don't know nothing about angles. Well, we know a little, but not much, right? But we can, now that we got those two triangles congruent, we can know something about the sides. So what can we say now? MZ is congruent to MY. That is true. What lets us say that? Corresponding parts. That's right. CPCTC. MZ is congruent to MY because of CPCTC. So we said this is congruent to that, right? Because of CPCTC. So now what? It's isosceles, because why? Yeah, what is that with isosceles? Is that a theorem or is that a definition? It's definition. Triangle ZMY is Isosceles because definition of isosceles. Blank. What other questions from this lesson? All right, let's learn about rectangles, shall we? So, what is the definition of a rectangle? What? It's quadrilateral, right? What does a quadrilateral mean? No, that's a square or a rhombus. You went too tight. It has four sides. Quadrilateral, right? So what makes a quadrilateral rectangle? And I ask instead of just telling you because you've known what a rectangle is for 5,000 years, right? What's a rectangle? So a square is a rectangle, but not every rectangle is a square though, right? So what's a rectangle? What all things have to be true for something to be a rectangle? Bro, no. What? What do you mean? You're not using the word I think you mean. Not square, but square in a carpentry sense. Yeah, all the angles are 90 degrees. True enough. What else makes something a rectangle? Because a parallelogram, no, excuse me, just kidding. Yeah, 4 right angles. That literally is enough. I think that's a proof of a rectangle. We'll see in a second. If memory holds true. So yeah, that's true. What else is true about a rectangle though? It is, the sides are parallel, that's true. Actually, there's as we get more, in these last few lessons, as we kind of narrow in tighter and tighter on more and more specific quadrilaterals, there is usually the definition is like this big thing, like, or it's a quadrilateral, it's got 4 pairs of 90-degree angles, opposite sides are congruent, which is another rectangle thing, and whatever, you kind of get this big thing, but if you just take the definition of the last thing, then you can shorten the definition some. Like a rectangle is a parallelogram with four 90-degree angle sides, right? 4 right angles, right? You can kind of get it even tighter and tighter. Now, so everything that's true of a parallelogram is true of a rectangle, but more things are true. And one important thing is the first theorem, right? And that is that if we have a rectangle, if we know something is a rectangle, because it is got right angles. Now, we also have a theorem. Do y'all remember the parallelogram theorem that could be super useful for proving something is a rectangle? Something with right angles. Do y'all remember what I'm talking about? I know it's in there somewhere in your brains. So there's a theorem for a parallelogram that says if one angle is a right angle, they're all right angles on parallelograms. So if you know something's a parallelogram and you know it's got a right angle in it, poof, rectangle, right? So if we have a rectangle, this is a rectangle, trust, because I said it is, right? Go even further with our definition and we'll make it even furtherly true. So rectangles, if a quadrilateral is a rectangle, then it has congruent diagonals. So in this pseudo example, AC is congruent to BD, right? So if it's a rectangle, if quadrilateral is a rectangle, then its diagonals are congruent. Right? Easy peasy theorem. No big dealio. Let's do a guided practice using that idea. Let's do guided practice number 1A on the bottom of page 423. So we got that picture with parks and whatever else, and we know that the way it does these pictures is it can be simplified down to these are just line segments, right? We don't have to have these crazy compound paths and all this other nonsense, right? This is labeled as PQRS, PQR, and S, and this is T, I think, right? Yes, T. Okay. And for 1A, it says if TS is 120 meters, find PR. TS is 120 meters. And there's one other important part of that. One other important thing that is true that we're going to need to solve this one. This is 120 meters, and we're supposed to find PR, the whole thing. That's an R, apparently. There's two pieces of information that are important. One that we haven't discussed, and something else that's important, and that is that in a rectangle, just like in a parallelogram, the diagonals bisect each other. They're also congruent, right? So that means this is congruent to this, is congruent to this, is congruent to this, right? So PR is over here, but we know this one. So if this one is 120, then this one is also 120. And if this one's 120, then the whole dadgum thing is how big? 240. So it's 240 meters. 240, the measure of PR is 240 meters. Easy squeezy, lemon peasy. Hey, so what about 1B? So it says, for 1B, it says that if angle PRS is 64, we unfortunately have to assume degrees because the book is dumb. So PRS, so this one, is 64 degrees. Find the measure of angle, excuse me, the measure of angle SQR. So SQR, so this one. All the big angles, the PSR and SRQ, et cetera, right? I went too many et ceteras. There's only two of them. Anyway, you get the picture. They're all right angles, which means their measure is what? 90. They add up to 90. So if this one's 64, because these are also parallelograms, right? Then this one's 64 and this one's 64. So how can we find this one? If it adds up to 90, how could we find the missing one? We could subtract 64. We could do the measure of angle SQR equals 90 minus 64. Therefore, it equals 28 degrees. Easy peasy. All right. What else can we know about rectangles? Well, nothing. But the converse is also true, right? So if if it's a rectangle, if a quadrilateral is a rectangle, then we can say the diagonals are congruent, which means that if we can prove that the diagonals of a quadrilateral are congruent, then it's a rectangle. Easy peasy. What? Nothing? All right, I'm going to assign you homework and then kick you to the curb. Homework. Pages 426 to 427, numbers 10 through, make sure, 32 evens. All right, ready, set, go. Have a great weekend. Do your schoolwork. Bruh.